terms. And finally, we shall deal with differential equations, whereby we have first order differential equations, second order differential equations, separate integrals, linear equations, whereby we shall also deal with the integrating factor. Then we shall also deal with the practical applications of differential equations. So for today, we shall just deal with the introduction, and we shall also deal with the beginning part of integrals. So first of all, what we have to know is that integration is the process of obtaining an original function from a given gradient function. What do we mean by gradient? Gradient. For example, if we have an expression y which equals to 2x plus 1, and you are told to find the gradient. Find the gradient. There they mean that you have to find the derivative of y which equals to x plus 1, which you numerate as dy over dx. So the derivative of 2x is the same as 2, and the derivative of any constant value like 1 is 0. This is now the derivative of dy. The derivative dy dx equals to 2. So here we have found the gradient. So for integration, we have to move from this other part of the differential, then we get this other value. For example, if they tell you to find the derivative, the integral of 2, the integral of the integral of 2. And if they want you to go back to this original function. So in simple terms, integration is the opposite of differentiation. So now let's do this opposite. We are having 2. We want to go back to this other part of 2x plus 1. So our equation will be find the integral of 2, which is it. So for integration, remember we use this side, the integral of 2 with respect to x equals 2. So now for here, 2x initially is the same as 2x over 0. Why do we say that 2x is the same as 2x power 0? Because any number power 0 equals to 1. And that means x power 0 also is the same as 1. 2 times 1 is 2, okay? Here there is an invisible one here whereby we are going to be using x power 0. We introduce our x power 0 because x power 0 is 1. Any number power 0 equals 1. So now we continue here, whereby we shall be having 2x, okay? For integration, you add 1 on the power, okay? And then you add that sum of the power. You add 1 on the power, and then you divide that sum of the power below. So now it will be 0 plus 1. So it will be giving us 2x power 1 which is the same as this other part. We are having 2x plus 1. We are having our 2x and we have a constant. But now here you are not sure if the constant is 1 or 2 or 1 million or 1,000. So you just put there and an arbitrary constant because you are not sure of this. So that is just an introduction from the other part of differentiation. So now assuming if dy over dx equals to x power n, okay, then y equals to, if you are given the derivative, then you are told to look for y, then y equals to x n power 1, okay, over, as we have done the other side, over n plus 1 plus an arbitrary constant, where c is the arbitrary constant and n should not be equal to -1. Therefore, the integral of x power n with respect to x is the same as x power n plus 1 over n plus 1 not forget our general formula, which is ax power n plus 1 over n plus 1 plus an arbitrary constant. Now we go on to find the integral of x cubed. The integral of x cubed with respect to x. Now here it will be x power 3 plus 1 over 3 plus 1, which should be the same as x power 4 over 4. Don't forget to include the arbitrary constant. That means the integral of x cubed with respect to x equals to x power 4 over 4 plus the arbitrary constant. Then we go to our last part. This is now part C. We are looking for the integral of x power half with respect to x. So now it will be the same as x power half plus 1 over a half plus 1 plus the arbitrary constant, which is the same as x. A half plus 1 is the same as 3 over 2. Then it is here also over 3 over 2. It will be giving us 2 over 3 x power 3 over. That means now the integral of x power half with respect to x equals to 2 over 3 x power 3 over 2. Don't forget to put the arbitrary constant plus the arbitrary constant. So now here the key takeaway here we have the key concepts. The first one is integration is the opposite of differentiation. The other one is the integral of any function ax power n with respect to x is the same as ax power n plus 1 over n plus 1 plus the arbitrary. So we shall start